Hey all, welcome to yet another problem of the day. Let's solve the lead codes daily challenge. The problem is maximum difference between a node and the ancestor. Given the root of a binary tree, find the maximum value v for which there exist different nodes a and b, where we want to find the absolute difference between the a is a dot var minus b dot var, and a is an ancestor of b. A node A is an ancestor of B if either any child of A is equal to B or any child of A is an ancestor of B. So we want to find their absolute difference between any two ancestors. That is, if we consider this as our binary tree, so that can be a difference between 8 minus 3. The difference between 8 and 3 is 5. The difference between 3 and 7 is 4. The difference between 8 and 1 is 7, and likewise, but we cannot say the difference between the 1 and 10 because this 10 is not an ancestor of 1 or 1 is not an ancestor of 10, but we can say it as 10 and 13. Likewise, we want to find their absolute difference. So how can we solve this problem? So for this second example, the absolute difference, which is maximum is 0 and 3, the absolute difference is 3, so we return 3. So for this for example 1, the absolute difference 8 and 1 is 7, so that is the maximum that we can get, so we return 7. So how can we solve this problem? So to solve this problem, my thought process is like, to get the maximum absolute difference, we obviously want to know some sort of maximum value and a minimum value. If we know this two, we can just find the absolute difference of max minus min, and we can keep track in our answer is nothing but max of answer comma this absolute difference of max minus min, max bar minus min bar. So this can be the formula for to find the keeping track of the maximum absolute difference. But how can we do this? We can just do a traversal. First, we want to make sure that we are having a difference between the ancestor and a child node. A child node in the sense, the node that is down of those ancestor node. So to make sure that, what we can do is we can do a traversal. We can do any in-order pre-order postal traversal. By doing those traversal, we can just keep track of maximum and the minimum value. So let's say I am calling the function, let's say I'm calling some function solve with the function with the root, and the maximum value is root of val, and the minimum value is also root of val. Currently I'm starting from this root, so the maximum and the minimum is 8 itself. So then I will go to its left. When I'm going to its left, I obviously know that I'm keeping track of this maximum. This is, let's say this is the maximum. Let's say this is the maximum and this is the minimum. So while going to its left, I will update the minimum and the maximum. While going to its left, I will update the minimum and the maximum. So whenever I'm going to its left and right, I'm going to pass the maximum and the minimum till the current node, so that I can keep track of the maximum and the minimum in their path. That is, I will not be calculating the maximum and minimum between this 1 and 6. I will be calculating this path 1 8 3 1, and if I'm going to its right, I'm calculating this 8 3 and 6. So that how can I do is, I'm consider we are calling this function. When I'm calling this function, before saying the thought process, it will be very difficult to just say I will draw and show the recursive structure how it goes. So before that, what I can do is I will write the structure of the code so that you can get a clear understanding. So let's say get max difference. I'm going to have a function get max difference. I'm passing the root and the root of val and another root of val. This is nothing but the max and the min. So I'm going to have it as private since I don't want to expose the function outside. So max difference I can have a global variable that is going to keep track of the maximum difference, ancestor difference. So I'm going to return the max difference at the end of the day. So I can define the function get max difference that is going to return me a void get max difference where tree node star root and an int max val and int min val. So what I basically do is if my root is null, then I can just return this will be my base case. If not, then what I will be doing is I will calculate the max difference. I will keep track. What I will be doing is max of the max difference comma the absolute difference of max val minus the min val. So this will be my formula to keep track of the maximum ancestor difference. Next I will be passing this. Next I will be calling this function by root of left. If I am going to its root of left, my max val, let's say I can have a current variable int cur max val is equal to max of max val comma the root of val. Similarly, so now I will have another variable that is going to keep track of current min val is nothing but the minimum of the min val or my root of val. So I will pass for my next function call. I will pass the curve max val and the curve min val. I will give a dry run before that so that you will get an understanding. Here I will be passing the root get max difference of root of right. So let's say this is the structure of the code. So what does this happen? I will call the function with this root, then the max val is nothing but 8 and 8 initially. So this is my function call that I'm doing in the driver code. So when this function is called, I'm taking this base condition, it will not get executed. Then I will keep track of this max difference. Now the max difference is initially 0. Let us have the max difference declared here. Max difference is equal to int min, since I want to keep track of maximum value. So int min. So now the max difference will be updated to 0. Next, the current max val will become max val is nothing but the max of 8, which is 8 again, and here the current min val is again 8. Then I'm going to its left. While I'm going to its left, again I will be calculating the maximum difference, which is nothing but 8 minus 8, which is 0. Again the max difference is updated to 0. Next, the current max val will be the maximum of 8 comma 3. So the current max val will be 8 in the next recursive call, and the current min val will be the minimum of 8 comma 3, which is 3. So here 8 comma 3. So we have updated this. Now we will be calling the next recursive call again. It will be going to its left. While going to its left, you can see the maximum difference will be updated to 5. So the maximum difference is nothing but the max difference between the absolute value of max and min, which is 8 minus 3, which is 5. So now my max difference will be having 5. So after this, what I will be doing is I will be calling the next recursive call from this node to its left. So while going to its left, my current max value will be 8 and the current min value will be 1. While calling this function, I will be ending up in this base case, but I will not be executing this line. So what I can basically do is I can just put this line here so that I will execute this before this base condition itself, so that I keep tracking of this answer as well. So now my max difference will be updated to 7. So now I will be trying to go to its right recursive call. In right recursive call also 8 and 1 will be the max and min value. So again the max difference will be 7. Now what I will be doing is I will be standing at this position and I will be calling towards right recursive call. This line will be get executed. So while doing the so what will be happening is the maximum value till now is 8 and the current min value till now is 3. So while coming to this node, the absolute difference that will be updated is still 7, and then I will be calculating the current max val is 8 and current max min val still stays the 3 as well in this right recursive call. Then I will be going to its left recursive call. While going to its left recursive call, the same thing applies, and this will get executed for the number of nodes in this tree. So hope you understand the path that it takes, how it is updated. So this is the structure of the code. Now let us try to run our code. Let's see whether it is getting accepted. Okay, sorry, I have written this line. I'll just comment this line. Now let us try to run our code. So it gets accepted for both the test case. Let's see the constraints. There will be minimum number of nodes will be 2. So obviously it can achieve some answer. So now let us submit our code. Superb, it gets accepted. Hope you like the solution. That time complexity will be order of n and the space complexity will be an order of n since it is using an extra stack space, auxiliary stack space. So hope you like the solution. Let me show again. So this will be my code. So let me know in the comments if there are any suggestions. Let us see in tomorrow's LeetCode Daily Challenge. Until then, bye.